Yes. Can you hear me?
Yes, we can.
All right.
Okay, cool. We are good to go. Max, welcome to St. Josaphat. Do you want to start by introducing yourself? We got 27 of us here today. You're unfortunately facing the back awkwardly, but you can watch yourself.
Oh, that's great. I can see myself seeing you. Okay, can you guys see me? The window's kind of... What if I try this way?
Somewhat blurry. Okay, that's better. That's better.
Can you see me? Great. Hello. How are you guys today? Fantastic. So my name's Matt. I grew up in Regina, and that's all I need to know. Sorry, I grew up in Regina. Undergrad at the University of Regina, and then went where I did some plasma science. So plasma is the fifth state of matter, and
Hey, Matt, hold on a sec.
really interesting work on that. Hello?
Hey, can you, do you have like headphones or something? Your audio's cutting in and out.
Let me try.
Okay.
Hello? Is this better? If I can talk in my phone?
Way better.
Much better. How much better? 10 times?
Yeah.
Okay, great. All right. So, so I did. Why don't I just start again? I don't know if you could hear anything I said. My name's Mac. I'm from Regina. I grew up there, did high school there, and then moved to Texas and did my undergraduate work at the University of Texas, where I did plasma physics. And now the last 4 years, and am doing my PhD in something called engineering systems. My work currently is all about how scientific collaborations form and how we can use those to help develop new areas of the world. So I would like to talk to you guys today a little bit about some cool things that are going on in science, and hopefully you guys have some interesting questions. I think we will be okay. I just got an email about 10 minutes ago that there was a chemical spill here at MIT, and so like a little bit away from my building, but I have to quickly leave. You will know why. So anyway, that said, do you guys have any questions? Mr. Webb sent me some stuff that you guys have been working on in your science classes, but I thought maybe it'd just be best if we ask. You can ask any sort of questions you want.
So Mac, just to start us off, one thing we kind of mentioned was the research you did with cancer previously.
Yes.
Do you want to just explain that really quickly, and then we can jump into some questions?
Yeah, for sure. So I did plasma physics, and how plasma physics works is you take radio waves and use radio waves to bombard gases with high amounts of energy, and that essentially turns them as hot as the sun. So the sun is made of plasma. We create plasma. This doesn't sound at all like it's helpful for cancer. There is a group of researchers at my undergrad university that developed a technique to attach carbon nanotubes to cancer antibodies. Now, what are each of those? Cancer antibodies, whenever you get sick, your body produces antibodies to try to fight off that infection or virus or anything like that. And your body produces antibodies to try to attack cancer. It's not very good at doing at actually killing the cancer cells. So all our antibodies in the body, but they're not helpful. There are little tiny man-made structures called carbon nanotubes, which are essentially take carbon and create a very small tube, nanotube, a carbon nanotube, And if we attach these two together, we can essentially inject these carbon nanotubes into your body, and they'll flow all throughout your system and then get attracted to where the cancer is in your body. So now we have carbon nanotubes next to cancer cells. And there's a couple different ways that we can kill cancer with these carbon nanotubes. One that we were trying is using radio waves. Radio waves go through your body every day. That's how radio stations come to your car or whatever. And we don't have any harmful effects on our body. And so I was actually doing lab testing on cancer cells with these carbon nanotubes, and we see any heating, and we actually found that we could kill cancer with them. And since I've left, we're now working on doing some tests in sort of lab animals, so rats in particular. So, and they seem promising. There's some technical challenges that are there, but the science behind it. So yeah, and that was not at all. I'm not a science. I'm not a medical doctor or anything like that, and yet I was still able to contribute a little bit, a very small way, to the fight against cancer. So it was a really cool experience and something that I never expected that I would do any work on. But it was a really good experience.
All right, very cool. Okay, guys, who had questions? Put your hands up. I just want to see again. Okay. Jenna, do you want to ask your question? Come on over.
Oh, yeah, I think you're going to have to come over to the computer. I can't quite hear you.
I'll rephrase the question, too.
All right, so tell them your name and then your question.
My name's Jenna.
Hi, Jenna. I'm Mac.
Hi. This is kind of like a crazy question, but
yeah.
I don't want to ask it. It's like
no, you can totally ask it.
Definitely ask.
Awesome. I love crazy questions.
Okay. Just by your what's going on in the world and everything, do you think the world's gonna end anytime soon? I guess.
Yeah. No. I mean, sorry. Not yes as answer to your question. No. I think there's a lot of scary things out there. One thing that sometimes I think about is asteroids. They're out there and traveling around really quickly, and we have no idea. And frankly, probably wouldn't see them until it's too late to do anything about it. But I think. How do I put this best? I'm really hopeful. I think so. We have a lot of big problems. I think global climate change is something that we're going to have to deal with, and it's not our parents that are going to deal with it. It's us. It's us in this room. We're going to have to figure out how to solve that problem, and if we don't, there could be very dire consequences to the world. But I also think that we're able to do that. We will have the technologies and the will to sort of solve that types of problems. And yeah, things like asteroids, I think that they're a little bit scary. But it's also things that we could start to actually put some time into defending against. We could put up a whole series of satellites just to look for asteroid detection. Right now, I think it's something like 1,000 people in the entire world work on trying to detect asteroids. We could maybe afford to have 10,000. So I think that there's things we can do. But I'm not really all that concerned about the world. Yeah.
Okay.
Cool. That was a good question. That's not a crazy question at all.
Next question, Mac. Here we go. Introduce yourself.
Yes.
I'm Josh.
Hi, Josh. I'm Mac.
Hi.
when you explode those cancer cells in like people, like where does the cancer go?
Yeah, so this is I think the big question that we don't really know the answer to yet. So right now, what would happen? So first we have a couple things that we have to deal with. One, we're injecting carbon nanotubes into a person. So right now we're just doing it on rats. We're not actually doing it on people yet. Because, one, we don't know what carbon nanotubes themselves do. They could be worse for humans than cancer. It's tough to think that there is something like that, but could be. 2, does it actually work, which we're pretty sure it does. And then 3, exactly your point. So if we kill all the cancer in your body, there's sort of 2 ways we've improved. One is slowly heating up carbon nanotube so that it essentially like cooks the cell. As gross as that sounds. But like stops it from being able to replicate. And then it would just sit in your body.
Yeah.
The second, more ambitious idea is to heat them up really quickly in order to make them explode. And once they're exploded, like cells explode in your body relatively frequently, and your body has a way of like taking care of cell fat that have like taken care of that waste. And that would be the ideal thing, is to like explode them and get your body to take care of the cancer. But that's harder to do without also exploding the cells around.
Yeah.
Which is right now the big problem that we're trying to avoid. When you go to radiation treatments, it kills the cancer, but it's also hurting you, right? And so, like that's what we're trying to do, is have a targeted treatment that just targets cancer, but doesn't hurt the person around it.
Yeah.
The cancer. But I think this is a great question, and hopefully we can solve it.
Yeah.
Here's another question. Abby, why don't you come over?
Hi, I'm Abby.
Hi, Abby. I'm Mac.
Okay, so Mr. Webb like told us about flying cars and stuff.
Yep.
So like, how would they like work? Would they like work with like the same way cars do, or would they like something different to them?
Yeah. So we people have been talking about flying cars for decades, and it always seems like they're about 10 years to 20 years away. Right now, they might actually be away. So a couple things that are difficult with flying cars. One, before we think about how the flying mechanism actually works, if we think driving is hard, being a pilot is way harder. So training everyone to be a pilot and needing to be a pilot takes, I don't even know, 100, 200 hours of time in the plane, plus all sorts of little things like that. So that would be very difficult to put it concisely. But we're actually moving really close to having self-driving cars.
Oh.
Sorry, by close I mean they already are here. They work. The Google cars have been in exactly 2 accidents the entire time that they've been on the road, which is like 2 years. One of the accidents, it was a human driver that was driving it. That doesn't count. And then the other time, it got rear-ended by a human driver. So they work, and they're awesome. So any sort of like flying cars, we would probably want them to be so that we don't have to go through all that type of training and that sort of thing. But flying cars, I mean, there's a couple different ways that you can think about it. One, you could think of like small little helicopters And there's actually like prototypes of like bikes that they look like motorbikes, but have instead of the front and back wheel, have front and back like propellers, and then you like drive them around. It's really cool. You should totally watch the video. And then, I mean, that's probably the most realistic way that we could do it. There's also maybe some ways we could work on magnetic levitation. So essentially, Earth has a magnetic field, and we might be able to use that with some magnets to make us hover off the ground. But probably the most likely is sort of things that are very similar to a helicopter, but much smaller, so that you can use it personally, or maybe your family, something like that. Yeah. Does that answer your question?
Yeah. Yeah.
Cool.
Okay, who else has questions? Let's see your hands.
Thanks, Abby.
Yeah. You put up your hand, guys. We'll get to you. We're going pretty quick.
Hi, I'm Caitlin.
Hi, Caitlin.
I got a question. Why is the sky blue?
What a great question. Okay, so what's the best way to do this? Okay, so maybe I need to draw. So have you guys started talking about reflection or refraction yet? I know that you guys have started talking about optics. Okay, do you guys know what refraction is? Yeah, so this is how light bends when it enters some sort of substance, right? Now, the different light that we see is made up of a whole bunch of different waves. So this is light is vibrating, and it's a wave, and when it hits the surface, depending on how fast it's vibrating, it will bend more or less. So what happens in sky is blue, and so if we think about a rainbow, like red, orange, yellow, green, blue, indigo, violet. That's what we see. And our red is the shortest wavelength, and violet is the longest wavelength. So when we hit a visible light against a surface, the red light bends the most, and the orange light bends a little bit less, so on and so forth, until violet light doesn't very much at all when it hits a surface. So when we look around, if you actually look outside right now, I don't know what the sky's like in Regina, but you'll see the area directly around the sun looks pretty much white. If you can look at the sun without damaging your eyes, the area around is pretty much white. That's because all of the light is coming into the atmosphere, and it doesn't hit the atmosphere on an angle, it hits it straight on. And then all that light comes to your eyes, and you see white. Now, once you get a little bit of an angle, so if we have, so if my head is the atmosphere, right, any light that's coming straight down, like this, is just gets to us and is white light. Any light that comes on any sort of angle hits and gets turned. Okay? So, based on the size of our Earth, pretty much the only light that gets bent down to Earth is the blue, indigo, and violet. So all the reds and all of the yellows and all the oranges get filtered. But our sun doesn't produce orange, indigo, or violet light because of its temperature, which is good for us because if it was producing that, it would be like 100 times as big, and we would no longer be here because it would be much, much bigger. So we only see the blue light. So we're actually also seeing the indigo and the violet, but we don't really, there's not very much of it. So it's blue. Then as the sun goes down, you end up with those oranges and reds that were previously filtered out. You can now see, and that's why sunsets look so cool. So the light is always there, but it's hitting the atmosphere and refracting away. So none of it ends up in our eyes. Yep. So then oceans are blue because of reflection. And it's blue reflecting off of the sky onto the water and then back into your eye. Because if you look at a glass of water, like a glass of water is clear, and we know that water is clear. So oceans are clear. The sky is blue, reflection. Oceans are blue because of reflection. Cool. Does that answer your question?
Yep.
Awesome.
Okay, who's questions? Haley, do you want to ask your question?
Also, if anyone has any like follow-up questions or like, oh, you explained all that and I didn't understand, like please ask me again, and I can try it again in a different way. Hello.
I'm Haley.
What's your name?
Haley.
Haley. Great to meet you, Haley.
How did Ebola start?
Oh, okay. How did Ebola start? The very first case, or how did this Ebola outbreak start?
The first case.
The very first case. So I don't actually know, and I don't know if So let me talk a little bit about Ebola. Ebola is
She asked, how did Ebola start?
yeah. So the question is, how did Ebola start? And so Ebola is a disease that affects fruit bats. So, and in fruit bats, it doesn't really do anything to them. It's kind of like, it just gives them like fever. It's kind of like the flu. To fruit bats. But to humans, it's much, much more deadly. And so how humans get Ebola is they eat fruit bats, eat fruit that fruit bats have started eating, or eat other animals who have fruit that fruit bats have started eating. So it all comes from fruit bats. And in fruit bats, as far as we know, it's been in their population for a very, very long time. And really, it's only been in the last like 200 to 300 to 400 years that humans have been in contact with fruit bats so frequently in that part of the world that we've seen like transmission from fruit bats to humans. So how did this outbreak start is really interesting. I have a friend who is very involved with this right now, and so what they found was there's many different types of what they call okay, so it's called hemorrhagic fever. What it means is that you get so hot that you start bleeding from everything. And some of these are more deadly than others, let's say that. And we have better treatments for other things. And so in that part of Africa, there's a really common hemorrhagic fever called like Lassa fever. I can't remember the exact name. I'll follow up with you guys, but I think it's Lassa fever. And so when this girl she lived in a rural village and somehow came in contact with Ebola, and then went to the local hospital. And Lassa is not contagious via touch, or because Ebola is like any sort of fluid, so even sweat. And you can transmit that. But so they didn't isolate her for Ebola. They isolated her for Lassa fever, which is much more difficult to pass between humans. And then she pretty much got that whole hospital sick. Before they realized it was Ebola, all of those patients traveled, including some that went to the big city in Sierra Leone, and then they got a whole bunch of people sick there. And then by the time we figured out it was Ebola, there was already 1,000 people who were sick and passing it on to other people. So some good news, like we in Canada or the United States should not really be all that concerned about Ebola. I don't mean to say it's not a big deal. So how you die from Ebola is you get dehydrated. You can't really drink water, and so the only way is to have to have IVs with like saltwater solution. And here in Canada or the United States, that's very, very common, and we could handle like a large influx of people and still have enough IVs to be able to treat the problem and get you through the Ebola until you're no longer sick, and then you can recover. In these areas, the medical services are simply overwhelmed, and they cannot provide enough fluids to people to get them through. Every person who's been evacuated, like every American and Canadian, there's a couple Italians who got Ebola, like doctors who got Ebola, they've all survived because as soon as they come to a hospital here, there's enough resources that we can get them through. So I'm not worried about us. I'm worried about Africa, because especially that part of Africa is just overwhelmed. Does that answer your question? Do you have any more questions about Ebola? No? Okay. That was a good question. Thank you.
Okay, hold up, guys. Mac, while we're here, just before we take another question, can you tell us a little bit about MIT and maybe some of the hacks that happened there?
Yes. So MIT is a really interesting place. It's definitely some of the smartest people I know here. And there's a culture here of something called hacking. Now, this hacking is a little bit different from the hacking that we get in the popular media. Hacking at MIT means physically taking something and turning it into a big joke. So, for instance, we have a large dome on our campus. It's like 8 stories tall. And this has been the site of many famous like pranks and hacks. So when the last Lord of the Rings movie came out, they put a big giant ring around the dome, like the last ring. They also took apart an entire police car of the MIT police and took it up on top of the dome and reassembled it, and then just left. And so the police had to go up and get their police car back. There's also a building on campus that's extremely tall with a whole bunch of small windows, and they replaced all of the lights in the entire building with multicolored LEDs, and then put a joystick on the ground, and it's like 18 stories tall, and then it became a giant Tetris game, and anyone could play Tetris on this huge building. And it's the tallest building in Cambridge, which is this side of the river. Yeah, so it's a lot of really funny pranks, and every year there's about 2 to 3 new pranks, and there's a whole ethic behind it, and people having fun. We all have these rings, and on the inside of the ring, there's actually, I don't know, you won't be able to see, but there's a map of Canada. All of Canada is covered in tunnels and is connected to strange small little tunnels. And the idea is if you're running after you should look at your ring and find the best route to take you around the people trying to stop. So it's a lot of fun. But it's also a place where some very serious work gets done, and it's a lot of work. I mean, you guys might have heard of some of the really cool work that happens here. Movies like Good Will Hunting. Well, actually, that's really Good Will Hunting. Has anyone seen Good Will Hunting? Wow.
Nobody, just crickets.
I did it.
Oh, you did? Okay, great. Yeah. That's great.
Okay.
Yeah, so if anyone has any questions about MIT as well, I can answer any of those. Or just college.
Go ahead.
Hello, my name is Alexander.
Hi, Alexander.
I have a question. Why did you get interested in engineering?
When did I get interested in engineering? Ooh, that's a good question. So when I was in grade 6 or 7, I first went to a science and engineering camp at the University of Regina, ICE. Maybe some of you guys have heard of it. And that was really fun and sort of started the idea of maybe doing science. And then when I got to grade 12, I started thinking about what I wanted to do when I got to college, and I really didn't decide at all. And so when I got to college, I was something called undeclared, where I just tried a whole bunch of things, and then made my decision from there. So I actually was able to get into this plasma physics lab and start doing actual real science before I decided that I wanted to pursue that. Then after I decided that I wanted to do physics, I sort of found that it was too disconnected from the real world, and I didn't think I was going to be able to help people like I really wanted to. And so engineering is sort of like a middle ground, where I still get to do interesting science, but my science is focused on and focused on real applied problems. And I absolutely get from what scientists do, and I still actually consider myself a scientist more than an engineer. But nonetheless, I'm still much more interested in applied problems and how we can actually help the world. Yeah. Cool. I hope that answers your question. It is, and I guess the short answer is it took a little long time. Yeah.
Hi, Mac.
Oh, hello. How are you?
Good, how are you?
Good.
I miss you.
Yeah.
Kyle and I basically work together now, so there's that.
Really? You guys are great. Do you guys like Miss Engel?
They don't like Miss Engel, but I like being here. So there's that. Yep. But I just want to say hi really quickly.
Hello.
Okay, I'll see you later.
I'll see you
Bye.
at Christmas.
Okay, see you guys later.
Sorry guys, Miss Angle knows Mac as well. Who has questions?
Max.
Okay, I need to approve Max's first, so that's
Okay.
Hunter, Josh, after this. Max, can you come over here?
Okay. I'm Destiny.
Hi, Destiny.
Just a quick question. What favorite show do you watch? Do you like to watch?
What favorite show?
Yeah.
Like TV show? So, I know that I should say theory. But, so, last night I was watching Big Bang, and there's a show that comes on after Big Bang Theory, which is called Scorpion or something like that. I don't know, I just watched one episode. But it's about geniuses and they solve problems. And I really like that show. So that might be better than Big Bang Theory. There's also a fantastic show on Netflix. Oh, I don't know if it's on Netflix. It's called Eureka, and it's also about a scientist. It's really funny. You guys should all try to watch it. Yeah.
Cool.
Yeah, what is your favorite show?
Oh, The Vampire Diaries.
All right.
Okay.
Next, you should introduce yourself.
Hello, my name is Max, and I have a question.
Yep.
Why is there no gravity in space?
Okay, good question. There actually is gravity in space. There's gravity everywhere. Okay, so in space, what's happening is you're falling at the same rate that your spaceship is falling. So you guys are just falling together. And what's happening is, for instance, when you're in orbit around the Earth, if you think about, okay, so if I take a cannon on Earth's surface and I shoot it, it's gonna start going, and then it'll drop and hit the ground, right? And if I shoot it twice as fast, it'll go farther and then hit the ground. And then if I keep shooting it faster and faster, eventually it's going to start dropping as much as the Earth is curving, and just going to keep going around and around. So that's what's happening, is these spaceships are going so fast, and gravity is pulling them that they just go around in a circle. And so the best example of this is if you're on, for instance, a school bus. And I don't suggest trying this. Or I guess, so if you take a ball and throw the ball up in the air, like you're going along at 100 kilometers an hour. When you throw a ball up in the air, it doesn't just like stop. It also is going 100 kilometers an hour with you. So imagine if the school bus was going like 1,000 kilometers an hour. 1,000 kilometers a second. Right, and then what would happen is everything is just moving all at the same speed. Yeah. So that's what's happening. And have you guys heard of the airplane that gets weightlessness on Earth? Maybe. So it's called the Vomit Comet. And what they do is everyone goes up in the airplane together, and then they like dive really quickly, and then while they're diving, everyone's falling at the same speed. And then it's like you're weightless, and you can do that for like 35 seconds. And then it like stops, and then goes back in, and does that like 100 times. And so that's like to experience that weightlessness. Yeah. Does that answer your question?
Yeah.
Great.
Thank you.
Okay. Who else has questions? Alvin, you have a question?
You're mad.
Yeah, that was a good question.
You should introduce yourself.
Hi, I'm Albany.
Hi there. Hello? Oh, great. Oh, wow. That was a
My
bad
question is, how are
There's a lot of delay. Okay, I think we're good again. Can you ask your question, Albany?
okay? How are the rings of Saturn and Jupiter made?
Great question. So the easiest way to describe it is, okay, so our sun, all of our planets and our sun used to be a star previously. Then that star exploded. It in what we call a nova, and all of that dust essentially exploded out. And then we have a big giant dust cloud. And then all of this dust starts spinning around. And the dust in the middle, where it's most concentrated, ends up clumping together. And eventually, over time, there's enough gravity that there's so much compression that there's so much something called fusion. And that is what a star is. And then we have all the rest of the clumps on the outside. And then in these clumps, there's like little tiny clumps of dust, and they start sticking to other clumps, and they start sticking to bigger clumps, and they start sticking to others, and then you end up with planets start forming, or what will become planets. And these start spinning too. But on occasion, they don't collect all of the dust and particles that are in their immediate area. And so you end up with other dust spinning around it. And these are rings. Okay? And these so the rings of Saturn are really just dust that are particles that are spinning around the planet. So on smaller planets, they're not spinning fast enough, and typically they'll end up clumping together and forming moons. So that's where our moon comes from. That's where Mars's 2 moons come from, and Jupiter's many, and Saturn's many more. But on bigger planets, they're spinning so fast that often you can't actually get the particles to clump together well enough to form a full moon, and so you end up with exactly rings. Does that make sense?
Yeah.
So, and it's interesting because many billions of years from now, we actually think that before our sun explodes in a couple billion years, we think that like the rings of Saturn will actually turn into a moon or two. And so we think that eventually the rings of Saturn will go away. Yeah.
Okay.
Cool.
Thank you.
Cool.
Okay, who's questions?
Wait, what's the little the thing? Oh, okay.
Hi there.
Hi. So, like, what are some of
What's
the
your name?
hacks
I'm
that
sorry. What's your name?
Tia?
Tia?
Yeah.
Great.
What are some of the hacks that you've done?
Oh, no.
Oh, okay.
So, typically it's the undergraduate students. It's like the 18 to 22-year-olds who do the hacks. And
How old are you?
25. So most PhD students are too busy to do hacks. The real reason is that we're not. So each hack probably takes 300 to 400 hours to prepare. To plan out how you're going to get stuff up onto the dome, or if you're going to do this or do that. So it's really difficult to put enough time into that. Yeah. So I'm sorry to disappoint you. I haven't done any. Yeah.
Okay. Yeah.
Sorry.
Yeah. What's your favorite hack?
My favorite hack. Okay, there's two that are pretty cool. Okay, so one, when they released the last Harry Potter movie, they figured out how to put like a lightning scar on the dome and projected a dark mark into the air. And it looked really cool. It looked like there was like some oh no. What are the bad people in Harry Potter? Death Eaters. Death Eaters. The Death Eaters, right? So they look like they're Death Eaters. But my real favorite one was when they announced that they were going to do the next Star Wars movie. They turned the dome into a big R2D2, which was really cool.
That's cool. Yeah.
Okay. Cool.
Bye.
All right, guys, we have about 5 minutes left. Okay. Gusto? Yes. Come on over.
Hi.
Hi there.
I'm Gusto.
Hi, Gusto.
And my question is, you know how Earth is in space?
Yes.
And in space there's gravity, like as you said, but there's like kind of no gravity, and you still float around in space. Why don't we float here in Earth?
Okay. Great question. So, what happens is, okay, so every time you get a large collection of mass, it starts creating gravity. So, even on like a small asteroid, there's still a little tiny bit of gravity. Then, you go up to bigger asteroids, they have a little more. Then you go up to like the moon, which has, I think, 1/9 of Earth's gravity. So if you weigh 100 pounds here, you'd weigh 10 pounds. So yeah. So actually, I'm pretty sure if you have a bike on the moon and bike really quite fast and then hit a ramp, you can just like keep going off the moon. So you don't have to be going that fast to like escape the.
Okay.
So what ends up happening is that everything in our solar system and in our entire universe is pulling on us all at the same time. So the closer you are to a large object, the more it's going to pull on you. And the more it's going to exert gravity on you. So there's actually a point sort of between the Earth and the Moon where they're both pulling on you exactly the same. And you'll just sit there. You'll just like float right there. And then if you move a meter towards the moon, you'll get sucked into the moon. And if you move a meter towards Earth, you'll get sucked into the moon. And so there's this same thing between the Earth and the Sun and any other two big objects. Yeah, so there's actually some... So all of gravity is always pulling on us at once. Just we're so much closer to the Earth, and the Sun is it's very large. So if our Sun was many times larger, or was, for instance, like a black hole, we could actually be like pulled off the surface of the Earth. Because there's so much more gravity. Yeah. So here on Earth, we're actually being pulled by the Sun. So for instance, if you measure yourself when the Sun is directly above you, the Sun is going to be pulling on you a little stronger, and you actually weigh less if you weigh yourself at midnight. When the Sun is pulling on you and the Earth is pulling on you. Yeah. So if you want to lose like 1/1000th of a pound, weigh yourself at noon.
Okay.
Cool. Does that answer your question?
Yes.
Great.
Okay, Matt, we only have, well, less than a minute here. Can you tell us the newest, coolest thing that you know that's happening in science that might be interesting to us? Grade 7, right?
Yes. So you guys will have heard of photosynthesis, right? This is how plants create their food. And we've recently figured out how to hack photosynthesis. So one, we think we know how to increase the efficiency a lot, which would mean that we could grow crops that are like would grow even in very conditions where there's not a whole lot of sun. And two, we could also potentially put them into non-plants. So you could, the cool thing is we might be able to like create animals that can just use the sun for food. It's really cool, and in particular it's cool because we might be able to create some really interesting algae that could be used to create biofuels, so we don't need to use oil nearly as much as we do right now. So there's some really cool implications. Yeah, hacking photosynthesis is pretty cool. Yeah.
Okay. We still have a little time until our next class transitions here, Matt.
Oh, okay.
If you could give these guys, these 27 students here, one tip on how to be a better student or a more successful scientist or anything like that, what would you tell them to do?
I think that the number one thing is that there's no such thing as stupid questions. I think a lot of asking questions is absolutely critical. When I was going through school, didn't understand things, and many times I didn't ask, and so I never really learned it very well, and I had to go back and relearn it, and that slows things down a lot. So don't be afraid to ask questions, because if you don't know what's going on, I can guarantee that there's at least 3 to 4 other people in the class who also don't understand it. I just don't want to ask the question. So I think that's the number one thing, is that always be curious and always be okay asking questions. I love answering questions. Mr. Webb loves answering questions. Honestly, everyone loves answering questions. So yeah, ask questions. That's my thing. Yeah. Is there more time? Should I give another time?
Hold on, Matt. Okay, let's save that for next time. That's a deep question. Yeah. Okay, Mac, one last question. What time is it in Boston right now?
It is 3:43.
Okay, cool. Oh, too bad.
Yeah.
All right, we gotta go for today. They're switching to social studies, but thanks,
Okay.
Mac. Can you guys all say thanks? All right,
Thanks,
we'll
guys.
see you
This was
later,
a lot
man.
of fun.